Okay guys, today let's talk about the halogenation of alkenes and more specifically a subset of bromination called a halohydrin formation. That's just a big mess of words that means we are adding Br2 over water, which ultimately is going to give us the addition of just a single bromine and a hydroxy ion in place of a double bond. Now this is one of the few mechanisms that I tend to see come up on tests where the professor will ask you to draw the whole mechanism out. Fortunately, it's quite easy provided that you keep track of your partial positive and negative charges and understand that the water molecule, which ultimately gives way to the hydroxy ion or the OH group, is going to attack the more substituted side of the original alkene. Okay, so those of y'all that have worked with me before know how much I stress this theme of negatives attacking positives in organic chemistry, as it tends to explain almost everything. So when we see that our first step here is going to be this pi bond attacking this bromine and then popping this other one off, this should seem odd to you because, right here between this sigma bond and pi bond, I've got this area of electronegativity. So that would be a negative, right? And then certainly bromine is super electronegative. So this seems like a negative attacking a negative. Now what this is called is a temporary dipole moment, and here's what happens. So think about all the electrons that are shared between these two bromines. As this pi bond approaches this blue bromine on the left, it's gonna push any kind of electrons that way, okay? Because they're gonna flee the incoming source of electronegativity. As a result, it's for just a split second, it'll leave this blue bromine temporarily devoid or lacking in electrons, just enough to where it can establish kind of a partial positive charge that ultimately is going to allow this bond to form. So otherwise, you tend not to see negatives attacking negatives in this course, as those would repel each other. So in your next step, you're going to have this molecule here. You're going to have this bromine here, and I'll keep everything color-coded for you so you can follow along. Let's keep track of lone pairs as well. So for a split second, there's going to be a carbocation here. Split second, I don't even know if it can be isolated. And of course, remember, negatives attack positives. So here's your negative, here's your positive here. So this is going to form this bridge intermediate called a bromonium ion, if I remember correctly. So now I've got this. Draw it in blue. And our methyl group carbon A is up here, like so. And let's keep track of these charges. So again, you can just kind of see how everything works. I'm going to have partial positive charges on both carbons 2 and 3 because they are connected to a very electronegative bromine. And for a split second here, bromine is actually going to have a plus charge on it. 1, 2, 3, 4, 5, 6, 7 minus 6 plus 1. So we're going to draw that. Irrelevant for the time being. So at this case, or at this point in the reaction, our water molecule is going to come in and attack carbon 2. So let's draw that nucleophilic attack. So that's going to be too many bonds coming out of carbon 2. Someone has to go. Bromine says, I'll take my 2 bonding electrons back like this. And then you're going to have this molecule here. Now let's invert this stereochemistry. We've got water, single lone pair, +1 formal charge, methyl group A, like that, and then this bromine down here, like this. I can't leave anything with a charge on it. So at this point in the reaction, we need someone to come along and deprotonate our water molecule, which ultimately will give way to the OH. And I have 2 different things that can kind of act as bases here. Either the bromine that I popped off in the first step, the orange one, or another mole of water could come in and then deprotonate this. We'll show the orange bromine acting as a base here. -1 charge. So again, this is still explaining negatives attacking positives. I've got bromine with the -1 formal charge. I have partial negative here, partial positive, partial positive, partial positive, because anything with partial positive means it is more electropositive than whatever it's attached to, oxygen in this case. So bromine's gonna act as a base. It's gonna take that proton. The bonding electrons can stay with oxygen. And then I'm left with this as my final answer. So I've got methyl group A on a wedge, I've got this OH group here and my bromine down here. And so these are going to be anti to each other. And since we formed two new chiral centers at 2 and 3, we would also need to include this molecule's enantiomer. So if you found this video helpful, but you need more in-depth explanation or want to see some more practice problems worked out, head on over to orgogoat.com. And if you're interested in private tutoring, or if you want to see a concept explained that you don't see on our YouTube page yet, shoot me an email at orgogoat@yahoo.com.